I want to look at a function that is a little different than what it first appears. If we were trying to investigate the limit of cosine of 1 over x as x approaches 0, we would choose x values that were getting closer and closer to 0. So let me choose some x values. Let's say 0.001 to start with, and then 0.0001, and then 0.00001. So they're getting closer and closer to 0. Now look at the values of the function cosine of 1 over x for these values. If you put in 0.001 for the x, you come up with 0.56238. Put in 0.0001, you get negative 0.95216. 0.00001, you get negative 0.99936. Well, it looks like then the function's values are getting closer and closer to negative 1. Now look at what happens when you plug in a value even closer to 0. All of a sudden we jump up to 0.93675. Okay, add another 0 and we get negative 0.90727. Add another one, and we get negative 0.36338. So it looks like it's starting to kind of flip-flop all over the place. Now, to understand what's happening here, let's look at a specific value that I'm plugging in for the x. I'm going to look at one that makes it easy for me to actually calculate the values. I'm going to look at x's that are of the form 1 over n times pi. So I'm going to put in first x equal to 1 over pi. Well, if I put 1 over pi for the x, then that means I'm looking at the value of cosine of pi, which cosine of pi is negative 1. Then I'm going to put in x equal 1 over 2 pi. Then 1 over 3 pi, 1 over 4 pi, and so on. Okay? Calculating these values is easy because now I've got cosine of 2 pi, which I know is just the same as cosine of 0, which is 1. Cosine of 1 over 3 pi would be cosine of 3 pi, which I know is back to negative 1 again. Cosine of 1 over 4 pi, or 1 over 4 pi, would be cosine of 4 pi, which is at 1 again. Now, look at these particular x values. 1 over pi, 1 over 2 pi, 1 over 3 pi, these values are actually getting closer and closer to 0. But look at what happens to the function values. Negative 1, 1, negative 1, 1, negative 1. It just continues to flip-flop back and forth between negative 1 and 1. Now, I want you look at the graph of this thing. So here's the values. The 1 over 2 pi, it's up at 1. Here's 1 over 3 pi, negative 1. Over 4 pi, 1. 1 over 5 pi, we're at negative 1. As those values are getting closer and closer to 0, right here, this thing is flopping back and forth, just oscillating back and forth between negative 1 and 1. So the smaller the x gets, the closer it gets to 0, it's still oscillating between negative 1 and 1. So this is a case where as close as we can get to 0, I'm going to have another one of these values, 1 over some number times pi, even closer, that's still going to go up to 1, and another one that'll still go down to negative 1. This is a case where this limit does not exist. So we've got cosine of 1 over x as x approaches 0. So just putting a few values in isn't sufficient for you to conclude that the limit doesn't exist. But if you just happened upon this particular sequence, 1 over 2 pi, 1 over 3 pi, 1 over 4 pi, and so on, that's approaching 0, and find the function values, it's real easy to see why it's oscillating back and forth, and so it will never have a limit. So that's a nice function to kind of be familiar with, just so you see where a limit doesn't exist sometimes.